All right, now let's continue a little bit more detail here. So let's take a look at the units for voltages. So if we look here, the units in this case, electric field is newtons per coulomb times R, which is in meters. So if we look, we have a newton meter up top. Well, what is a newton meter? Force times distance. Smells like work. Smells like energy family. So a newton meter is a joule. So if we actually define voltage, the voltage is actually joules per coulomb. So if we take a look at that, that's absolutely true. Okay, now I want to digress and go back a little bit and then go revisit electric field. Now, in this formula here, we have an integration. So let's suppose I wanted to solve this for electric field. So if I took this, I could take the electric field, pull that out of there. How do I reverse the integration sign? Well, everyone knows that you take the antiderivative of it, you take the derivative of it to reverse the integration sign. So if we do that, E is going to end up being equal to the derivative of V with respect to dr. So electric field can be thought of as, let's think about the change in the voltage divided by, say, the change in the distance that we travel. Watch out for that minus sign, it can come and get you. So let's go back over to our electric field part of the board, and let's write down our new friend. Electric field can be thought of as a potential change divided by a distance change. Negative D, change in the voltage with respect to the change in the distance that it travels. And then this gives us our electric field. All right, now the next thought is this. We've got potential. Voltage is the nice name that they gave it in electricity. And I've been itching to do this, but I was thinking about it in terms of potential energy. So if we think about potential energy, last year we would say U, actually we'd say PE last year, and then we end up with mgh. All right, and we talk about M, who are we talking about here? We're talking about M1, the little thing. So what has potential energy? Well, if we look here, we say that this pen has potential energy relative to the Earth itself. So it's the little guy that we say mgh. Not the mass of the Earth, it's the object that's trapped in the field itself. So if we go back here, we can actually look and rewrite this once again. We could say that the change in U is equal to mg, the change in the height. So once again, it's not so much what the height is, because 0 is an arbitrary thing. Isn't the change in the potential energy due to the change in the height itself? All right, now, if we go back, we can go back and solve this. Let's solve this for GH. So if we look here, GH is going to be equal to, taking this, and we're going to end up with the, well, let's do change in H. So we have G, change in H, is equal to, if we move this over here, take the M1, put it underneath there, so we have the change in the potential divided by M1. All right, and for purposes of clarity, let me just rewrite that. So G times the change in H is equal to the change in U over M1. Okay, now, if we look at electric land, let's take a look at its potential energy. So we say U is equal to, now this is electric potential energy. Don't charges trapped in electric fields also have the potential to move and create damage or whatever they're going to do? We can use them to actually do some work. So if we look at the potential energy here, instead of M1, we're going to say Q1. Okay, instead of GH, our analog for that is, oh, GH is like the voltage. So we would say that, and we would say V. All right, now, if I really want to think about it, the change in the potential energy is equal to Q1, the person that's trapped in the field. Gravitationally-wise, it'd be like the pen. And then it's really the change in the voltage. It's the change in the potential that creates the change in the potential energy, like so. Notice the units here would also be joules for the units, and these would all be in joules. Just like we would over here, these would all be in joules because we're talking about that it's actual energy.